Continuing with solutions to the Unit 2 review. Number 12, tell whether ordered pair represents a function. So I'm just going to go ahead and list these in terms of inputs and outputs. So I just kind of relisted them. And remember, if the x repeats, it has to have the same y. And so since none of the x's repeats, I'm okay. So that is a function. Number 12 is a function. Okay. 0, 0, 2, 2, 4, 4, 6, and 8. So once again, none of the x's repeat, so that is also a function. Okay. And looking at the last one, 0, 0, 1, 5, 2, 6, 1, 4. And you can see these ones repeat, right? So that means it is not a function because they have different y's. Okay. Scoot that over so you can see, sorry. Moving down, we want to graph this by making a table of points. So this is nice because they gave us which ones to plug in, so I'm just going to plug it in. So I'm going to work it out over here. I'm going to find f of negative 3, and that equals negative 4 over 3. Be careful to watch out for that negative sign. And I'm going to put that over 1. Now remember, when you multiply a fraction, right? When you multiply a fraction, it's you multiply the tops and the bottoms, right? So f of negative 3 equals, that's positive 12 over 3 minus 3, 4 minus 3, and that's a 1. So negative 3, positive 1. Okay. And then we'll do f of 0, and that equals negative 3. So 0, negative 3. Okay. And then last one here, f of positive 3 is negative 4 over 3 times 3 over 1 minus 3. And that's negative 12 over 3 minus 3. That's negative 4 minus that, and that's negative 7. So positive 3, negative 7. Looks like it's right there. And that looks like a linear relationship, so that's good. It means I did it right. And there's the graph of my line right there. Number 4 here. Gene is ordering some Nike Elite socks from East Bay. They cost $14 and shipping charge is $4. So I'm going to go ahead and set up an input-output here. So this is the number of socks, and this is the cost. So if I buy one pair of socks, it's $14 plus a $4 delivery charge or shipping. So that's $18. And so 2 pairs of socks is going to be $28 for the socks, but still only $4, right? So that's $32. And then this one here is going to be $46. So looking at this, you can see that my change is $14. That's how much I'm charging, right? And then, so I'm looking at going, okay, well, so I'm going to say y equals 14x, okay? But the problem is I've got to figure out what to start with. So looking at this, I'm going to go, okay, well, I'm going to plug one in here. So I'm going to plug in a 1 and an 18. So I'm going to say, kind of run out 18 equals 14 times, I'm going to make that plus. I got to figure out what to add. I mean, a lot of you could probably figure out just by looking at it, but I want to kind of go through it. And I'm going to plug in a 1. That should give me 18. Well, that gives me 14. So I am 4 short, right? I am 4 short. So I'm going to say, okay, so really the actual answer is 14x plus 4. Sorry. Plus 4 equals y. Use the function rule on the cost of 3 socks, including the shipping. So I did it this way here, but I want to use the function, right? So y equals 14 times 3 plus 4, right? And 14 times 3, right? 42 plus 4, and that equals 46. All right. So for number 17, we're going to graph the function rule and see if it represents a function. So 0, negative 3, 1, 0, 2, 3, and 3, 6. So right about there. If I graph this, left to right, okay? That's assuming it's continuous, but it might be discrete, so it could just be these points here. And either way, that passes the vertical line test, so that is a function. Next one here, we're going to determine if it's linear or nonlinear, and how many quadrants does the graph have values in. So this is definitely not linear, so this is nonlinear. And you can see here, it's going this way, so it's never going to come down here. So I'm only going to be in quadrants 1 and 2. I'm only going to be in quadrants 1 and 2.